So today we will see the enhancement type MOSFET and its working. In the previous video we saw the working of p-channel depletion type MOSFET. So here first we will see the n-channel enhancement type MOSFET. So here is its structure. We have p substrate, then we have drain and source of N plus type material, and then we have an oxide layer, above that we have a metal layer, and above that we have a gate terminal, and at the bottom we have a body terminal. And we know that our source is taken as reference, so its voltage will be considered to be 0, or we can say that our source is grounded. Now here first we will see some conditions. So our first condition is VGS equals to 0 and VDS equals to 0. So when we don't apply any voltage at gate and also we don't apply any voltage at drain, our current will be 0. That is, we can write no ID flows, or ID equals to 0. Now our second condition is VGS equals to 0 and VDS equals to negative. Here also our current will be 0, because until and unless we apply any voltage at gate, there won't be any channel formed between source and drain. So due to absence of channel, no charge carriers will flow from source to drain, and therefore no current will be there. So no ID flows, or we can write that ID equals to 0. Now third condition is that our VGS equals to 0 and VDS equals to positive. Still our gate terminal is having 0 voltage. So whatever we apply at drain terminal, that doesn't matter. So here also we will have no ID flows, that is ID equals to 0. Here ID represents drain current. Now here we have just written directly that when VGS equals to 0 and VDS equals to negative and positive, in both the cases our ID is 0. But now we will see the signs behind them. So let me remove this first. Now for the second condition, what is the second condition? That VGS equals to 0 and VDS equals to negative. That is, VD equals to negative, because our source is having 0 voltage. So this is our drain, this is source, and this is oxide layer, this is metal layer, and this is gate terminal, and this is source terminal, and this is body terminal, and this is P substrate. And we know that our N type material looks like this: positive ion paired with electron, and there are many such pairs. So when we apply here negative voltage, here we will have a positive ion in this, and we know that our P substrate, that is P type material, looks like negative ion paired with holes. So in P substrate we will have negative ion paired with holes. So those negative ions of P substrate will be here, and due to this a weak electric field will be formed here. That is weak electric field. Because we know that for a strong electric field we need positive voltage at the drain terminal, because our drain is of N plus type material. So when we need N plus type material to create a strong electric field, we need to apply their positive voltage. So that reverse bias is created, and then depletion region gets increased, and we can get a stronger electric field. But here, since we are applying negative voltage, so our electric field will be very weak. And these electric field, that means this weak electric field won't be able to attract the electrons of the source. So it will just move the holes of the P substrate, because in P substrate we also have holes with negative immobile ions. So weak electric field will move holes of P substrate, and here our electric field's direction is from drain to source. So our holes will also move from drain to source, because we know that holes move in the direction same as that of electric field. And for the current to flow, we need our charge carriers to flow from source to drain. And here we can see that our holes move from drain to source. So it's just the opposite of what we want. Therefore, ID will be 0, because holes moving from drain to source is just useless. Now we will see the third condition, that is VGS equals to 0 and VDS equals to positive. And VDS equals to positive means VD equals to positive. So now this is our P substrate, this is source, this is drain, oxide layer, metal layer, gate terminal, drain terminal, source terminal, body terminal, and here we are applying positive voltage at the drain. Due to this positive voltage at the drain, here we will have strong electric field. And due to this strong electric field, the electrons of the source will be attracted towards this. So here we can write that VD equals to positive, that means reverse bias is created, and this reverse bias means depletion region increased, and due to this increase in depletion region, we can write that we will have electric field and that electric field will be strong. So we can write that strong electric field will be created, not just electric field. Strong electric field will be created, and the direction of electric field will be from drain to source, and this strong electric field will attract electrons of source. But since there is no channel for the travel of charge carriers between source and drain, so the electrons which are attracted due to this electric field won't be able to travel from source to drain. They will just recombine with the holes present in the P substrate. So we can write here, first let me move this. electric field attract electrons of hole source, but electrons won't be able to travel to drain because of absence of the channel. They will just recombine with the holes of the P substrate. So since they will just recombine with the holes of the P substrate and they won't be able to travel up to drain, so there won't be any current, because what is current? Current is just the flow of charge carriers, and that flow should be from source to drain. So here, since our electrons won't be able to travel from source to drain, so there will be no current. Therefore here ID equals to 0. Now we will see the fourth condition. So what is fourth condition? Our fourth condition is that VGS equals to positive, but this positive voltage is very less in magnitude, and VDS is equals to positive. Now, what will happen now? Let us see that. This is source, this is drain, and this is oxide layer, this is metal layer, it is gate terminal, here we have drain terminal, here we have source terminal, here we have body terminal, and this is our P substrate. So now, here what is written? That our VGS is positive. So let us make it positive. Positive means here it will have this positive terminal, and here it will have negative terminal. Now, our VDS is positive, so our drain terminal will have positive voltage. Now, due to this negative terminal, electrons will travel from here to P substrate, and in P substrate what we have? We have negative ions paired with holes. That is, here we have so many negative ions paired with holes. Everywhere. So these electrons from this negative terminal will come and go to the P substrate, and there they will recombine with the holes of the P substrate, and then what will be left? We will be left only with the negative ions. When all the electrons will recombine with the holes, so only we will be left with negative immobile ions. But these immobile ions won't be able to create the channel, so still our current will be 0. So when VGS is positive but it is less in magnitude, our current is still 0. But after a certain VGS, that is, if we keep on increasing this positive magnitude of VGS, we will see that after the recombination of all the holes of the P substrate, these electrons will travel and they will form here a channel. They will come and they will form here a channel. So because of these electrons forming the channel, this channel is of N-type material. N-type, that is, we have N-channel formed. And since it is a P substrate and our channel is of N-type, so we will write here that it is inversion layer, because we have P substrate and in that P substrate we form the channel and it is N-type, which is just the inverted form of P. P and N are opposite to each other. So this is also known as inversion layer, this channel. Now we can write here that when VGS is positive but less in magnitude, electrons from the negative terminal will recombine with the holes of P substrate, but there won't be any channel formed. So here we can see that when VGS is positive but less in magnitude, electron from negative terminal will recombine with the holes of the P substrate, but there won't be any channel formed. And when we increase this VGS, so we can write that here also. When we increase VGS after a certain value, electrons from the negative terminal form the channel and this channel is of N type and substrate is of P type. So it is called inversion layer. So when we increase VGS, then after a certain value of VGS, we see that electrons from the negative terminal are still going into P substrate, and there they are forming the channel, and this channel is of N type and our substrate is of P type, so it is called inversion layer. Okay. Now, what that certain value of VGS is called, after which our channel is formed. So that certain value of VGS is called VTH, that is threshold voltage. So our fifth condition will be VGS is not only positive, it is greater than VTH. When VGS is greater than VTH and VDS is positive, we will have some finite ID. Now, let us move towards the sixth condition. So our sixth condition is our sixth condition is that VGS is greater than VTH and VDS is positive, but it is increasing. That is, it is not fixed, it is increasing. In the fifth condition, we had our VDS positive, but it was fixed. In the sixth condition, we have VDS positive, but it is increasing. So, we know that when VDS keeps on increasing, after a certain VDS value, our channel gets depleted of charge carriers so even though we have strong electric field due to increasing VDS, our current will saturate. That is, it will increase up to a certain point, as we saw this thing in the depletion type MOSFET also. So you can refer to that video also. That when we this is VDS and this is ID. So when we increase VDS, our current also increases. But after a certain VDS value, our channel, like this is our channel, let's suppose, our channel will be so depleted of charge carriers that even though we have strong electric field from this side to this side, our electric field will be, even though we have strong electric field, due to increasing VDS, our current will saturate. So our current will just saturate. And this value of VDS at which our current starts getting saturated is called VDS sat. And this value is ID sat. So this is our sixth condition. And what is the value of VDS sat? We remove this first. The value of VDS sat is equal to VGS minus VTH, or we can say VT. So VGS minus VTH is the value of VDS sat. So from here we can see that when VDS is less than 0 and VGS equals to 0 or whatever it is. So if we just see the previous condition, when VDS is less than 0, we have cutoff region. When VDS sat is greater than VDS, that is in this region, and also this VDS is greater than 0. So from here, that is from VDS equals to 0 up to VDS equals to VDS sat, our region is called linear region, because here we have linear curve, that is straight line. Then for VDS greater than or equal to VDS sat, we will have saturation region. can, instead of writing VDS less than 0, we can write that VGS smaller than VTH. And in all these conditions, we also need to write that VGS is greater than VTH, because that is the most important condition, because without VDS our current won't flow, whatever VDS is. So this is the first condition, that when VGS is less than VTH, we have cutoff region. When VDS sat is greater than VDS, that is VDS lies between 0 and VDS sat, and VGS is greater than VDH, we have linear region. And when VDS sat is less than or equal to VDS and VGS is greater than VDH, we have saturation region. So this is saturation region, this is linear region, and here we have cutoff region. So let me remove this also. Now we can see that this is ID and this is VGS. So up to certain VGS, and that certain VGS is called VTH. Up to VTH we have 0 ID, and after VTH our ID starts increasing. So we will have this type of curve. So this is curve between ID versus VTH. ID versus VGS. And this VTH is the threshold voltage before which ID is 0 and after which ID is increasing if we increase VGS. So that is it for today, and we will discuss after this in the next video. So thank you.